Hello everyone, I am here to present the project we are recently working on, Advanced Encryption Standard, guided by Professor Manish K. Gupta. This is the name of a group member, Bhavesh Pandor, Bhagirath Talavia, Siddharth Jadhav, Tarun Parasar, Raj Patel. What is AES cryptography? AES is a cryptography algorithm developed by two Belgian cryptographers, Johan Damon and Vincent Ridgman. It is a kind of a block cipher. AES block cipher relies on the substitution permutation network principle. It is performed using a series of linked operations which involve replacing and shuffling of a data input. AES takes 128 bits as input and outputs 128 bit of encrypted cipher text as output. Now question is, what is a block cipher? So a block cipher consists of a sequence of permutation and substitution operation. It is an iterated cipher which uses a round function and a key schedule to encrypt the plain text. Encryption of a plain text will proceed through n similar rounds. Some of the famous algorithms based on block cipher is SPN, Substitution Permutation Network, DES, Digital Encryption Standard, and AES, Advanced Encryption Standard. Now let's take a look into the AES. AES data encryption is a mathematically efficient and elegant cryptographic algorithm. It allows you to choose a 128-bit, 192-bit, or 256-bit key, making it exponentially stronger than the 56-bit key of DES. In terms of structure, DES uses the Fischl network, which divides the block into two halves before going through the encryption step, whereas AES on the other hand uses permutation substitution, which involves series of substitution and permutation steps to create the encrypted block. Now, how AES works? Basically, it depends on the size of the keys. Depending on the size of the key, if it is 128 bit, then we will proceed in 10 round, and further depending on its size. Important steps in working of AES algorithm are key expansion, initial round, round, and final round. Now, this is the block diagram shown here. Uh, Initially, there is a state of input which we will represent in terms of matrix. Then it goes through the sub-bytes operation and it will reach to some another state. And similarly, it went through the shift rows, mix columns, and 8 rounds key. And finally, one round will be over. There will be 10 such rounds. Okay. So now initial round. It is slightly different from other regular rounds in AES as it performs only 8 round queue transformation. We will look into it what it is. And last round is also slightly special as we don't do mixed column transformation in that round. Key expansion rational. So now we will have 128 bit in the key, but we will need 44 32-bit word for full encryption of given 128 block 128 bit plain text. Instead of having 10 rounds, it will need extra key for the initial round, which is, as I mentioned, special round. So we are in general expanding our 128 bit keys into 1408 bit using some algorithm. This algorithm is as shown in the block. Okay. Now question is, how robust is AES? AES is designed and tested to resist all the known attacks for DES. Now it took 5 years to check its robustness and standardize it. Knowing part of the key is insufficient to find any more keys. Fast on wide range CPUs use round constants to break symmetry, diffuse key bits into round keys, and enough nonlinearity to hinder analysis. Now, in terms of implementation, the algorithm is used in AES are so simple that they can be easily implemented using a cheap processor also and minimum amount of memory. Very efficient as it can be implemented by the means of hardware. Implementation was a key factor in its selection criteria where while selecting AES for standard encryption. Now it's code time. Let's run our code here uh, using this command \init. This is the terminal created by using while loop in our code. This is the C++ code I am running right now. Let's say we want to use this put operation. Let's say put a file name let's say AES, press enter. And now they will ask us for a 16-bit key which we will want to use to encrypt our data file using AES. Okay, let's say this is the key I am using right now. uh, Press enter. Now they will ask for file type name, say .txt. Okay, anything you want to write in the data file. Okay, hola hola. This is AES cipher exclamation mark. Okay, so now this is the encrypted data, uh, encrypted using this given key. Okay, now we want to again want to access the data, so we will need to do decryption. For decryption we will use this get command and write the file name again, that is AES. So get AES, press enter. They will again now ask us for the 16-bit key, and let's say we enter the same key again. Then it will show us the right decrypted code, that is hola hola. This is AES cipher. Okay, now suppose someone else comes and visit C or PC or something and try to access this file. uh, in that case they won't know that 16-bit key, and they will enter a random key. Okay. No, wait, let's say instead of 00 they enter 90. In that case they will not see any kind of data and see these random symbols which were generated using binary. Okay, now let's exit and move to the slide. Thank you very much everyone for listening this.